Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we will discuss that how a shared memory system can be implemented in an inter-process communication or IPC in the cooperating processes. When the cooperating processes are communicating with each other via shared memory, then a shared memory region is first need to be established. Now the process who is creating the process's shared memory is the owner of the shared memory region, and any other process which wants to communicate in the shared memory region can attach itself to the memory region. Then the processes can exchange information by reading and writing the information shared in this region only. Now the address space of the process that is containing the shared region of the memory has to be attached with any other process need to be communicated before the connection is established. Normally, operating system doesn't allow a process to control the other process's shared memory. Now in the shared memory system, 2 or 3 systems in the processes need to remove this restriction and begin to access the shared memory region. Now the processes control, it is not the operating system control that the data and location of the shared memory. Again, the process is responsible for not writing the data simultaneously in the shared memory. This shared memory system can be done by organizing a shared memory region should be established first, then information should be written and read from the shared memory. With the help of a producer-consumer problem, we can achieve that. In a traditional producer-consumer problem, a producer produces an input while the consumer consumes it. For example, a compiler is producing an assembly-level code which is then consumed by the assembler. Again, the assembler is producing an object-level code which is then consumed by the loader. It can be achieved in the client-server program too, where a server is requesting the services for the client. A client is requesting the services like HTTP images or sounds or any other files that is being produced by the server. Now this producer-consumer problem in a client-server text or any other context can be solved by a shared memory. This shared memory can be a pool of buffer where the producer can produce the file input and the consumer can consume the file output. A producer can produce an item while the consumer is consuming another item. Now the consuming and resuming synchronization must be done so that the consumer doesn't attempt to consume and process that the producer has never produced. So the synchronization can be done in letter-wise. Now the pool of buffer can be an unbounded one and a bounded one. In an unbounded buffer, the producer can produce as many items as it can and the consumer can consume the items from that buffer. In a bounded buffer, there is a capacity limit for the buffer size. The producer can produce items, say for an n size limit, n numbers of user services, and the consumer can consume the n services from that buffer. If the buffer is full, then the producer has to wait for some time, and if the buffer is empty, then the consumer has to wait for time to get access to the shared buffer. This way, shared memory system can get use of the buffer to actually get the information exchanged between the processes. Now, one concern in this illustration is that if the producer and consumer both try to access the shared memory simultaneously, then a problem will occur which can only be solved by the help of a synchronization. So that is all for the shared memory system in IPC. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.